Question number 61. Let's read the question, students. If uncertainty in velocity is 1 by 2m under root h upon 2 pi, then the ratio of uncertainty in position to momentum is. Student, for this question, we need to understand Heisenberg uncertainty principle, which states that, and the formula derived by that is delta x dot delta p greater than equals to h upon 4 pi. We'll be using this formula, but before that we are given with uncertainty in velocity, so delta v is equals to 1 upon 2m under root h upon 2 pi. Student, let's multiply delta v by m. It will be 1 upon 2 h upon 2 pi. Now students, on squaring both sides we get m delta v whole square 1 upon 4 h upon 2 pi. Now let's multiply both side by 2. We get 2m delta v square. Here we'll get h upon 4 pi. Now student, it is very clear that m delta v is momentum. So 2 into delta p square is equals to h upon 4 pi. That means 2 into delta p dot delta p is equals to h upon 4 pi. Also, according to Heisenberg uncertainty principle, delta x into delta p is equals to h upon 4 pi. So that means 2 into delta p is equivalent to delta x. That means delta p into 2 is equals to delta x. So student, that means delta x upon delta p, that is ratio of uncertainty in position to that of momentum, is equals to 2 upon 1. That is 2 is to 1. So the correct answer is option number 2. Moving to next question, students, which is question number 62. Let's read it. The values of all 4 quantum numbers for the last electron of potassium atom is. We are also given with the atomic number of potassium, which is 19. So I'm writing the electronic configuration of potassium. Atomic number 19 is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So this is the last electron. We have to write the 4 quantum numbers for this electron. And for this electron, the value of n is 4, which is principal quantum number. The value of L for s subshell is 0. And for 0, the value of m is also 0. And the value of s can be either plus half or minus half. That means the correct answer is option number 1. Moving to next question, which is question number 63. Let's read it. For hydrogen atom, correct order of energy of orbitals is. Student, for this question, first of all, we have to understand that for hydrogen atom, the energy of orbital depends only upon the value of principal quantum number, that is n. Higher the value of n, higher will be the energy of the atomic orbital. That means the correct order is represented in option number 3. The value of 2s and 2p is same because the value of principal quantum number is same, that is 2. Here the value of 3s, 3p and 3d is same because the principal quantum number value, that is n, has the same value. So the correct order is represented in option number 3. So the correct answer is option number 3. Moving to next question, which is 64. Let's read it. Number of standing waves in the 4th orbit of hydrogen atom is. Student, the number of standing waves is equals to shell number, which is equals to principal quantum number value, that is 4. Here it is 4. So the correct answer is option number 4. Moving to next question, which is question number 65. Let's read it. A 10-watt bulb emits 400 nanometer radiation. The rate of emission of photons is. Student, here, first of all, we are given with power, that is 10 watt, and we all know that power is equals to energy per unit time. And also we are given with the wavelength of the radiation, that is 400 nanometer. We have to calculate the rate of emissions of photons. So student, first of all, we will be calculating energy of photons, and the formula to calculate energy is hc by lambda, and the value of h 6.626 into 10 raised to the power minus 34, and then multiplied with the value of speed of light, which is 3 into 10 to the power 8, divided by wavelength, which is 400 nanometer, that is 400 into 10 raised to the power minus 9 meter, which is equals to 4.9 into 10 raised to the power minus 19. Now student, we have to calculate the rate of emission of photons, which is equals to the energy of the bulb, which is 10, that is 10 joules per second, and then the energy of the photon divided by the energy of the photon. So 4.9 into 10 raised to the power minus 19, which is equals to 2.04 into 10 raised to the power 19 photons per second. That means the correct answer for this question is option number 4. Moving to next question,